the last section in the writing equations unit is about scatterplots and correlation. A scatterplot is we get a scatterplot when two sets of data are plotted. Okay. They help us to spot trends. They help us then to also draw conclusions. And they also help us make predictions. So this is a great example of how algebra can help you in the business world. Now you have to understand that, of course, a lot of computers will do this sort of thing for you, but you need to understand why it works and what makes it work and where it's coming from. So here are some examples of some scatter plots. Weekly activities. So TV hours is one of the things that we've plotted, and exercise hours. So we have different variables, two different variables here, and when we look at it, it looks like as the TV hours are going up, the exercise hours are getting smaller. Okay, so we can spot a trend. That's what we just talked about, and say we might make a conclusion for why this trend is happening, and we can predict if somebody were to watch TV for 23 hours, we could make a prediction of how much exercise they probably got. Now this is, of course, these are general predictions, general conclusions. They don't work for every data point, but they do help us to get an idea of what's going on. Now when you look at your scatter plots, there are three types of relationships. We can have a positive relationship, and sometimes they're called correlations too. So three types of relationship or correlation. Those two words mean the same thing. So we can have a positive relationship. That happens when the slope of the line of best fit is positive, or when the points generally go upward. We can have a negative correlation, where the slope of the line of best fit goes downward, or the points tend to fall in a downward direction. Or it is possible that there is no relation or no correlation if the points are scattered all over the place. Okay, so let's look at these three examples here. It says determine what type of relationship is shown in each scatter plot and describe the situation. So you might imagine a line of best fit, or you can actually draw a line of best fit. Now a line of best fit should be straight, but we can see that for the most part these points are following this downward line. So this is a negative relationship or correlation. So determine what type of relationship is shown and describe the situation. And when you're describing the situation, we want to talk about what's called the independent variable first, which is always on the x-axis. The independent variable, I think you've learned in science, is the thing that we think is causing the dependent variable. But when you're discussing a relationship, you want to start with the independent variable, or the x first, which makes sense. Go alphabetical order. So you would say something like this: as TV hours increase, I'm going to run out of space. Exercise, what happens to exercise? Exercise starts to decrease. Let me do something here. So we'll write negative here. As TV hours increase, exercise hours decrease. Now you can discuss why that might be happening. So think about why that might be happening, and we'll talk about that in class tomorrow. How about B, fast food choices? So this has your fat grams and your calories. Where could we draw a line of best fit? Now this is debatable. Some people will say there is no correlation. Some people will say that there is. Now there are scientific ways to decide what the correlation or how strong the correlation is. But if we were forced to find a relation, it would probably be this direction. Okay. Now if it's no relation, generally it is much more scattered than this. Okay. But if you say no relationship here on a test, I would understand that. So for now, we'll say that this is this is a positive relationship because it goes up. Positive. And we would start with the X as fat grams increase, calories also increase. So in a positive relationship, as one increases, the other one increases. In a negative relationship, as the first one increases, the second one decreases. So it's really, the first one's always going to be increasing because we're moving upward in the number. And then it really just depends on if this one's decreasing, that's negative. If this one's increasing, it's positive. So C, automobiles. The relationship, of course, again, is going to be going downward, just like A. So this one's going to be another negative relationship. And we say as weight. Now we're talking about automobiles and the weight of the car and the gas mileage of the car. So as the weight of a car increases, the gas mileage is going down, decreases. Sorry, I'm running off the page. So identifying relationships and being able to talk about the relationships. And we'll talk about these. So come up with your, we'll discuss these briefly as to why these relationships are happening. So we've spotted the trend. In class, we'll talk about drawing some conclusions from what's going on in these situations. All right, the second thing we're going to do besides being able to identify our relationship, we want to be able to write an equation from a scatter plot and make predictions. So in this particular one, it's all about oil changes and engine repairs. So it says, the table below displays data that relate the number of oil changes per year and the cost of engine repairs. To predict the cost of repairs from the number of oil changes, use the number of oil changes as the X variable and the engine repair cost as the Y variable. So we have these data values. This is our X variable, this is our Y variable. And usually when they give you a horizontal chart like this, the top one is your X and the bottom one is your Y. And they've even plotted it for us. So this is oil changes per year. It goes on the x-axis. Cost of repairs goes on the y-axis. And then they've labeled the axes and plotted these points for us. They even drew a line of best fit. So A says describe the relationship. What kind of relationship is this? First of all, we know that it's a negative relationship. Negative relationship because it's going downward. But we want to also describe it. Not just the type, but put into words what's happening. So, as the number of oil changes per year increases, engine repair costs are going to go down, decrease. Okay? So if you keep your oil change is up to date, which reminds me I need to have an oil change, then when something goes wrong with your engine, you will be paying less to repair it in the long run, because you're taking good care of your engine. So we want to write an equation of the line in slope-intercept form. Now we're going to utilize what we learned in section 5.4 and 5.3. Writing the equations of lines. Now we want it in slope-intercept form, but the problem is we don't have a slope and we don't have a y-intercept. But we do have a whole bunch of points. Now the first thing you need to be careful of is that when you draw a line of best fit, the line must go through at least 2 points. And this line actually goes through 3, probably this one, and this one, and it goes through this one too. It's a little further off, you might say. So you need to draw a line of best fit that goes through at least 2 of the points. We generally want the same number of points above as we have below. This one's skewed a little bit. But I chose this point right here and this point right here. You need to choose only 2 points to write an equation of a line. Okay, so what we need to do is identify what these 2 points are, because we need to get them straight from the chart here. So this one is 3. We know the number of oil changes is 3. And the repair cost is $470 or something. So that's actually this one, 3 and $450. Now this one is the other one we're going to use, 5 oil changes and $300. So that's this one. So what might make this easier is to write these 2 points like we see points. And we'll write them up here. So 5, 300, where the x value is on the left and the y value is on the right. And the other one is 3 and 450. Now once you have these 2 points, and you might even want to write them next to each other, we'll do that. Okay? We want to write an equation of the line using slope-intercept form. But we aren't going to start with slope-intercept form because we've got 2 points, we don't know the slope. So the first thing we need to do is calculate what the slope is, the same way we always did. So we're using that formula, y2 minus y1 over x2 minus x1. So we get 450 minus 300 over 3 minus 5. When we simplify this, we get 150 over negative 2. And we simplify it some more and we get negative 75. So what does negative 75 really mean? Okay, imagine if it were negative 75 over 1. This represents your y values and this represents your x values. So for every 1 oil change per year, as you increase by 1 oil change per year, the cost of your repairs is going down by $75 in the long run. Okay, so 1 oil change per year, an increase of 1 oil change per year. So we'll save you $75. So if you had 2 oil changes in a year, you could save $150. So if you were increasing the oil changes by 2, okay? So we've got our slope here. It happens to be a whole number. It doesn't look like the other slopes that we've had because we're talking about a real life situation. So here's our slope, and we want to use point slope form. So we choose 1 point. Now I chose the 5, 300. So it's the same steps that we used here. Writing an equation of a line given 2 points. You calculate the slope, you choose 1 point, and use point slope form. Okay? So it's exactly the same steps, but now we're using real life situation. So we're plugging it into point slope form. Y minus 300 equals negative 75 times x minus 5. And then we just finish solving this and put it in slope-intercept form. So y minus 300 equals negative 75x plus 375. We continue getting y alone by adding 300 to both sides. Y equals negative 75x plus 675. Now this is your equation of your line of best fit. This represents the equation for this line. We've done that before, okay? But we haven't taken it a step further and used that to make a prediction because we weren't talking about a real life situation before. So here's the piece that we haven't done. Make a prediction for how much it would cost if you only got 6 oil changes per year on your Mustang convertible. So 6 oil changes per year. You need to ask yourself, does that represent the X value or the Y value? And that's easy to find. There's 2 places you can find it. You can go back up to the chart and you see the table and you see that the oil changes per year is your X, or you can look at your graph. Oil changes per year is on your X-axis. So we know this represents my X values. What we do is take this equation, we're going to plug 6 into the X value. And when we calculate it, we'll get a Y value, and that will tell us how much it would cost or how much we would spend on engine repairs if we got 6 oil changes per year. So we've got Y equals negative 75 times 6 plus 675. And then you just do the math here. This gives us negative 450. And when we add it to 675, we get Y equals 225. So make a prediction of how much it would cost you if you only got 6 oil changes per year on your Mustang convertible. It would cost about $225 in engine repairs. Okay? And so this is the only thing we're adding here. This is all things, this first section here, all things that we already know how to do. Writing an equation of a line when you're given 2 points. You just have to find the 2 points from the graph or look up at the table. Write that equation. Once you get to the equation, then the information that you give you is either going to be plugged in for the X value and you solve for Y, or plugged in for the Y value and you solve for X. But it's easy to figure that out if it's plugging in for the X or the Y, because you can look at the table or at the graph, or you can look at the table. Once it spits out a number, then that answers the question that we're making the prediction for. So we're not adding much more here. Describing the relationship, that's pretty easy. This is old stuff. This is the only thing totally new that we're doing. Tomorrow, we will do an activity in class where we will measure foot length in inches and your height in inches, and we will graph those and write an equation of that in class. So please make sure that you, if you don't completely understand this, go back and listen to it again and watch it again until you're sure that you are and confident that you know how to do this.